Okay, in this video we're going to have a look at how we answer the questions on the Core Science Higher Tier pre-public exam paper that Year 11 did at Kings Norton Boys School just before Christmas. So let's have a look through. So question 1 is a question about blood glucose regulation. It says the graph shows the concentration of glucose in the blood of two people and how this changes over a 2-hour period. A part 1 says calculate the difference in blood glucose concentration between person A and person B at 90 minutes. So it's simply a case of finding 90 minutes on the graph, looking at person A's blood glucose concentration, which is 12, person B's blood glucose concentration, which is 5, and then taking 12 from 5, which gives us the answer of 7. Part 2 says, using information from the graph, and you can see throughout this paper I've highlighted some of the command words, so we've got to describe the change in blood glucose concentration for person B during this 2-hour period. No point talking about person A at all. So it's a 2-mark question, so I'm looking for two things. I'm going to say first of all that the blood glucose concentration rises from 5 at the start to about 6.2 over the first 60 minutes. That's my first marking point. And then after that 60 minutes, from 60 to 90, the blood glucose drops back down to 5 again before recovering and increasing slightly at 120 minutes, and that gets me the second mark. Part 3 asks me to state which hormone a type 1 diabetic, such as person A, would use to control their blood glucose concentration, and that's just something you have to know, and the correct hormone is insulin. Moving on to part B then, we've got a multiple choice question here. Excess glucose is converted into glycogen in the, and we've got 4 possible organs, and you should, again, this is just one you have to know, that the glucose is converted into glycogen and it's in the liver. Okay, part 2. This is a question that loads of students got wrong on this paper. Type 2 diabetics, those are the people who've got diabetes more as a result of their lifestyle choices rather than the fact that they were born with type 1 diabetes. And type 2 diabetics, the way they control their blood glucose concentration is through exercise and controlling what they eat, particularly how much sugar they consume. You won't get any marks on this one, unfortunately, if you've said through insulin injections or insulin tablets or anything similar. That concludes question 1. Question 2 is about the nitrogen cycle. We've got ammonia in soil in a little block diagram here being shown moving towards becoming nitrates in soil, and again a multiple choice question. And the name of the stage where ammonia becomes nitrates is nitrification, so it is C. Part 2 then asks us to explain how plants use the nitrates from the soil. And again, this is one that you kind of have to know, but 2 marks. 1 mark for saying they use them to make proteins, and then the second mark is they use those proteins for growth. Okay, part 3. Describe, there's the command word again, how the overuse of nitrate fertilizers can cause eutrophication. So you need to be familiar with the concept of eutrophication, and to do that we could have a quick look at the BBC Bite-Size section on eutrophication. So here it is, and you can find the BBC Bite-Size website with a link here if you need to, but it's pretty easy to Google. So I found the page on eutrophication, and the 5 stages are loaded here, shown here. So the first one is nutrient load-up, which is excessive nutrients from fertilizers are flushed from the land into rivers or lakes by rainwater. So in other words, rainwater washes fertilizers from fields into the pond. The second thing that happens is that plants flourish, means they grow much faster than normal, and the particular plants that we are interested in are algae, which is a plant that floats on the surface of the water, looks green and spongy. The algae blooms, and it prevents sunlight reaching plants underneath that algae layer. Those plants then die, and they stop putting oxygen in the water because they can't photosynthesize anymore. Now they're dead, they're going to decompose, they're going to rot, and bacteria do that. But the bacteria use up oxygen themselves when they carry out that decomposition process, and that further depletes the oxygen in the water. The final stage of eutrophication is the oxygen levels get so low in the water, no life is possible, and everything in the pond dies. Okay, so let's quickly go back to the paper then, and that's what I've put here. Nitrate fertilizers washed into a lake causes the algae to grow, and it's important to say here that they grow faster than normal, rapidly, or you can say an algae bloom. And it blocks the light for plants below the surface. The plants cannot photosynthesize, they stop oxygenating the water. Decomposing bacteria then use up even more of the oxygen in the water, This process is called eutrophication. Now it's a 4-mark question, and I've got more than 4 points here, but obviously I can only have a maximum of 4 marks. So that answer would get me all 4 marks. Okay, a bit more about nitrogen then. So leguminous plants such as beans and peas have bacteria growing inside nodules on their roots. The diagram shows some nodules on a root. It says, explain the relationship between this bean plant and the bacteria growing in the nodules. So for relationships like this, where you've got 2 organisms living together, it's either a parasitic relationship or it's a mutualistic relationship. If it's mutualistic, both of the organisms get a benefit from sharing the same space as the other one. So it's 1 mark in this case, 3 marks in total. 1 mark for saying the relationship is mutualistic, and you can say that at any point in the answer. And then the other 2 marks are for explaining what the bacteria get and what the plant gets. So the bacteria get shelter, and they also get glucose from the plant, food for the bacteria. The plants get nitrates needed for growth from the bacteria. So the bacteria produce nitrates that the plant can then use for its own growth. 3 marks. Okay, on to question 3. This is quite a tricky one, and particularly it's difficult to photocopy these graphs easily to be easier in a real exam where the quality of printing is better. It says government campaigns try to persuade pregnant women to stop smoking because smoking can affect the birth mass of babies. The graph below shows a percentile growth curve for boys aged 0 to 36 months. The average baby will follow the 50th percentile line. What's the mass of the average newborn baby? Let's zoom in a bit for this one, although as you can see the quality still isn't brilliant. So the 50th percentile is this line here, and you can see on the x-axis I've got from birth to 36 months in baby age. So what I'm looking for here is to follow the 50th percentile line, trace it down, and see where it crosses the y-axis. So down it comes, and it's difficult to see, but I think it's £8. And that's what I've put the answer as there. If you can see it a bit different on your paper, if it's photocopied a bit clearer, then perhaps I've got that answer wrong there, but on this fairly dodgy scan of this exam, you can see it's a bit blurred, but I'm pretty sure it's 8. It then goes on to say that babies born to mothers who smoke often have a smaller birth mass than babies born to mothers who do not smoke. Calculate the difference in birth mass between a baby born on the 50th percentile and a baby born on the 5th percentile. So I already know the 50th percentile baby is 8. We now need to find the 5th percentile baby, so same procedure, follow the 5th percentile line down. Looks again to me a bit blurred at the bottom, but it looks to be £6 to me. So it's £8 minus £6, so that's £2 for the answer. It then says describe, so I need to make sure I describe how the difference in birth mass has changed by the time the child is 36 months old. So I need to basically say if it's gone up or down. So the difference in mass is much greater, and if you do the same thing again for a 36 months old using the graph, you'll see the difference is £6. But actually you can get the mark for saying the difference in mass is just much greater. Okay, question 4, thermoregulation. We've got a flow diagram to show thermoregulation taking place. We've got to complete a sentence. The type of control shown in the diagram is any of these control systems where when something increases back to normal and it switches off a process, and the process would be if the body was too hot it could be sweating, for example, then that's known as negative feedback. And again, it's just one of those that you have to know. The next one, the command word here is state, so literally you just have to write it down. State the part of the brain that controls body temperature. It's this grey blob at the back here on the diagram, and it is called the hypothalamus. You can be fairly liberal with your spelling there. I'm not even sure that's right, to be honest, but as long as you've got the word down, then you're onto a winner. Okay, it then goes on to say, describe one way in which the skin helps in the control of body temperature. So there's a few options you can give here. It's a 2-mark question. So because it says describe, we're going to have to state what it does, and then we're going to have to explain how it does it. I've chosen to talk about sweating. So I've said skin releases sweat, so I've said sweating in my answer, so that's the first mark straight away when the body is hot. And then I need to explain how that cools the body down, and so the way it cools the body down is the sweat evaporates and the evaporation takes heat away, and that's what provides the cooling. You could also say that when your cold hairs stand on end and they trap a layer of insulating air next to the skin and try and prevent heat from leaving. You can also talk about vasodilation and vasoconstriction if you wish, but I think they're coming up later in the question anyway. Okay, part C then, and this is one that quite a few students didn't know the answer to. Explain why humans need to maintain their body temperature at 37 degrees. That's because the chemical reactions, particularly the enzymes that help those chemical reactions in the body, work best at 37 degrees. If the temperature increases, then they can become denatured, and if you don't know what that means, it effectively means the enzymes don't work anymore. 2 marks for that one. Okay, so here we are then. This star means if we go back to the front of the paper, it would tell us that the quality of our written communication is going to be assessed. So we want to pay particular attention here to get things in a sensible order, to use appropriate scientific words, and to make sure we don't make major spelling, grammar, and punctuation errors. But if we want to, we can still bullet point the answer. So it says, explain, that's the command word, how changes in the volume of blood going through the skin help to maintain body temperature. So here we go. I have said that when too hot, blood vessels near the surface of the skin dilate, get wider in other words. This allows more warm blood to flow near the surface of the skin, which allows heat to be lost through thermal radiation. So that means the skin gives that heat as an electromagnetic wave. Don't need to worry about that too much for this question, but that's what it is. And I've said that that process is called vasodilation. Up to this point here, I can have 4 marks out of 6 for this because I've explained one of the 2 methods. I've named it specifically as vasodilation, and I've included a thorough description of how it takes place. To get the final 2, I need to describe the opposite process, which is vasoconstriction. So here we go. When too cold, the opposite happens. Blood vessels near the surface of the skin contract, reducing heat loss. This is called vasoconstriction. So as you can see, my answers in a logical order. I don't think I've made too many spelling mistakes. Maybe you can spot some. I've used appropriate scientific words like vasodilation and vasoconstriction and contract and dilate. Blood vessels, there's loads of those in there. They're not particularly difficult scientific words, but they're scientific words nonetheless. And that's a fairly good quality 6-mark answer. Okay, carrying on then. Onto some chemistry now. Fuels. Coal is a solid fuel. When coal is burned in air, 3 of the products are carbon dioxide, water, and sulfur dioxide. Give the name of the 3 elements that must be present in coal. On this question, loads of people put oxygen. It's not right, but it's not particularly wrong either. And that's because the oxygen comes from the air. So it is necessary, but it doesn't come from the coal itself. But if I look at the 3 products we've got carbon dioxide. Well, the oxide part comes from the air, but the carbon doesn't. I've got water. So water's H2O, hydrogen and oxygen. So again, oxygen comes from the air, but the hydrogen doesn't. And I've got sulfur dioxide. The oxide again can come from the air, the oxygen, but the sulfur can't. So the 3 that must be present are sulfur, carbon, and hydrogen. If I've got any one of those correct, I'd get 1 mark. If I've got all 3, I get 2 marks. Okay, we then have another state question, so we've just got to write something down for this one without any explanation. State a problem that can be caused by releasing sulfur dioxide into the atmosphere. You need to know that that causes acid rain. Not really much else to explain about that one. Okay, this is quite a good question. John's doing an experiment to find the percentage of oxygen in air at room temperature, and he used this apparatus here. We've got probably a boiling tube or a test tube with some copper inside. He's heating up the copper, and he's got a gas syringe. The copper powder in the test tube was heated strongly so that it could react with oxygen in the air in the apparatus. John stopped heating the copper when there was no further change in the reading on the gas syringe. At the end of the experiment, the apparatus was allowed to cool before the final reading on the syringe was recorded. This is because reading the volume while the apparatus is hot is dangerous. Well, to be fair, you do that without touching it, so it's not really that dangerous. The apparatus must be left to allow the reaction to finish. Well, he's already said that he stopped heating it when the gas syringe had stopped moving, so the reaction had already finished, so it's not that one. The third one, C, the gas must be at room temperature when the volume is measured. Well, that makes sense, that one, because when the gas is heated, it's going to expand slightly. When it cools, it's going to contract slightly, so if you want to measure it and get a fair answer, then you're going to have to measure it at the same temperature as you started, which I guess was cold room temperature, so you need to let it cool down, so the correct answer is C. For D, the copper expands when it's hot. It will expand, but a small amount, in fact a tiny amount, and that's not going to be significant for this question, so it's almost a case of C being the most correct answer. Okay, part 2. At the end of the experiment, not all the copper had reacted, so guess the reason for this. The simple reason is there's not enough oxygen in the apparatus, because if you see it's completely sealed, you can't add any more oxygen, so if you put too much copper in there, then it won't all be able to react because all the oxygen will be used up. Okay, it then goes on to say John's results were initial volume of gas 32 centimeters cubed, final volume of the gas 24 centimeters cubed. Calculate the percentage decrease in the volume of gas originally in the syringe. So the keyword, the command word here is to calculate. So let's have a look how we do that then. So I'm hoping that you know this from GCSE maths, but if you don't, here goes. If you want to calculate a percentage decrease, you work out the decrease, and so the decrease is going to be 32 centimeters cubed minus 24. You then divide that by the original amount, which was 32, and then that'll give you a decimal. And if you want it as a percentage, we times it by 100. And the numbers are quite easy for this. We get 25%. But obviously, I'd hope you put that into a calculator in an exam. Make sure you get it right. With percentage questions, one really easy rule of thumb to make sure you haven't got it wrong, because if this number's more than 100, well, you probably got it wrong. Okay. So it then says the percentage of oxygen in air at room temperature is 21%. John thought the answer to part 3 was the percentage of oxygen in air and was surprised that the value was too high. You can see here 25% is higher than the 21% we know for the proportion of oxygen in the air. John confirmed that he had not made an error when doing his experiment, suggest why the answer calculated in part 3 is higher than John expected. So you need to give a reason why that could be. And the reason is quite simple, although quite a few people didn't spot this. You've got obviously a measured amount of air in this part of the gas syringe, but you've got no way of measuring this amount of air that's already in the test tube or boiling tube, whichever one it is. And so actually, you've got more air than you've measured or read off the gas syringe at the start of the experiment, and that's the answer. It's simply to say that there was already air in the test tube. It's only 1 mark, so that makes sense. Okay, moving on to question 7. The photograph shows a limestone cliff face. Limestone, clearly everybody's favourite topic. It tells you that limestone is a sedimentary rock, and it says the limestone shown in the photograph was originally formed beneath the sea, and then earth movements forced the rock upwards to form the cliff. So it's told us this bit about the rock being forced upwards already. Describe how the limestone was originally formed and has become the cliff face shown in the photograph. So it's a 6-part question. There's quite a few marking points for this one, and I'm not going to show you the mark scheme. I'm going to go through what I think is the best answer for this one. Sometimes these mark schemes can actually do more harm than good. So I've said, you can see I've bullet pointed my answer. It's a quality of written communication assess question, so I'm going to pay attention to my spelling and keywords. So I'm going to say it was formed from the calcium compounds in the shells of dead aquatic organisms. Those organisms fall to the seafloor and build up in layers, and the weight of the layers generates pressure squashing out the water and forming solid rock. I've then said that limestone is a soft rock. Sea levels have changed, and the action of waves has caused the soft rock to erode away. And actually, that's pretty much enough to get you a 6-mark answer for this question. It's quite straightforward if you just stick to the basics. Okay, moving on. Okay, so here we've got an electrolysis experiment. We've got hydrochloric acid, and we're separating it out, and we can see we've got some chlorine already forming in here, but we've been suspiciously not told what this gas is here. So the first part of the question is a state question, so I literally need just to write an answer down, a word or something like that. And it says state the form of energy used to carry out the electrolysis, and it is electricity. There's a bit of a clue in the name. It then says chlorine gas is formed at one electrode. Name the gas formed at the other electrode. Well, if you look at hydrochloric acid, it sort of sounds like it's hydrogen, hopefully, and hydrochloric acid and chlorine. So we've already been told we've got the chlorine there, and so hopefully you can see, and you should have done this experiment in class last year anyway, that the second gas is hydrogen. It then says to describe the test to show that gas is chlorine, or the gas is chlorine, sorry. And the test for this is damp blue litmus paper. It turns red, and then it bleaches, which means the colour disappears. And then that gets you the marks of that question there. Okay, carrying on then as quick as we can. 9. Fuels. The photograph shows a multi-fuel camping stove designed to use various fuels. The stove can burn the hydrocarbon fuels, propane, petrol, kerosene, or diesel. And it's told you that propane is a gas. Hopefully you know that petrol and diesel at least are liquids, and kerosene is also a liquid as well. Suggest 2 reasons, so we've got to explain why it is usually difficult to burn different hydrocarbon fuels efficiently in the same appliance. 2 answers for this. The 2 that I think are the most obvious is to say that some are easier to ignite than others. So for example, drop a match into a beaker of petrol, you've got a fireball on your hands, drop a match into a beaker of diesel, and the match goes out. So I've said some are easier to ignite than others. Reason 2 is they could be in different states, and you can't burn a gas and a liquid in quite the same way in the same appliance. You've got to do something different with the liquid than you do with the gas. So just need to say could be in different states, and I've made it crystal clear by saying i.e. liquid or gas. Right then. It then goes on to say the fuels that can be used in the stove are obtained by the fractional distillation of crude oil. Which of these statements about the fractions is correct? So is it A, each fraction is a pure substance? No, that's not true. That's not true, not at all. Is it B, fuel oil is used as fuel for cars? Well, I've never heard of fuel oil being used for cars. Petrol and diesel, yes. Fuel oil, no. C, diesel oil is used as a fuel for some trains. Absolutely. In this country, if trains aren't electric, then they're almost certainly powered by diesel. And then D, some fractions of biofuels, by definition, they're hydrocarbon fossil fuels, they're not biofuels. So the only answer that you could get for that one is C. Okay, part C. I imagine most people looked at this and thought, crikey, I can't do any of this. But I think you might find you're actually wrong. So here we go then. Ethane, C2H6, is present in crude oil. Write the balanced equation for the complete combustion of ethane. 3 marks of this. If you can remember that burning is fuel plus oxygen makes water and carbon dioxide, and you can remember the chemical formulas for those 4 things, obviously you're told ethane already, then actually you can get 2 out of the 3 marks of this. So, for example, if I'd written C2H6, which is the ethane, plus just O2, and then an arrow, becomes H2O and CO2, I would get 2 of the 3 marks. 1 mark for these 2, and 1 mark for these 2. Only the 3rd mark of these 3 is for balancing the equations, and balancing is a bit of trial and error. You've got to get a situation where you've got the same amount of each element on one side of the equation as the other. So let's just have a quick look at the carbon and see if that works. So on the left hand side here, I've got C2H6, so I've got 2 carbons in every molecule of ethane. On the right hand side, I've got CO2. So in every single molecule of CO2, I've got 1 carbon. So to make these balance, I'm going to have more CO2s than I've got C2s. So I'm going to have 2 C2s, which gives me 4 altogether, 2 times 2. And I've got my 4 over here matching up. The hydrogens then. So on this side, I've got 6 hydrogens, H6. On this side, before I put the 6 here, of course, I've got 2 hydrogens, no more hydrogens in any of the other products. So if I want that to match up, because I've already multiplied this lot by 2, so I've got 12, I'm going to need 12 on this side as well. So 6 times 2 is 12. Then finally, I look at how many oxygens I've got. And so I've got 7 O2 on this side. So that's 14 oxygens altogether, 7 times 2. And on this side, I've got 6 here, plus 8 here, so the whole thing matches up and balances. If you're going to struggle with the balancing bit, make sure you get the chemical formula down without the balancing numbers first, and then it might even be worth just moving on with the rest of the paper and trying to balance it if you've got some spare time at the end, because the chances are it is only going to be 1 mark out of the 3. And it probably also is one of the most tricky bits on the paper. I certainly think balancing equations is pretty hard. Okay, so we're on to some physics then. So we're carrying out investigations with an electric motor, and we've got a diagram. You might remember these are Sankey diagrams showing the energy transfers, and it's pretty straightforward. Whatever goes in on here, so we've got 200 going in, we must be able to account for that coming out on the other side, because energy can't be made or destroyed. So, how much energy is wasted? We're told that 50 joules isn't wasted, and we put 200 in, and so it's pretty obvious, but I've written down the full calculation. 200 in minus 50 out leaves 150, and that all must be the wasted energy. So that's the answer to that one. It then says calculate the efficiency of the electric motor. The efficiency equation should be on the formula sheet at the front. The equation is the useful energy output divided by the total energy input, and then you can multiply it by 100 to convert it to a percentage. Now, whether or not you need to calculate this in your own head is up to you, because you should be able to see straight away that 50 is a quarter of 200, which means the whole thing's 25% efficient. But you can use the equation and get the same answer if that works better for you. The numbers aren't always that easy. Okay, question 11. Scientists have studied stars to discover how stars evolve. They know that stars form in a nebula when clouds of dust and gas are pulled together by gravity. Describe how this process continues for stars much more massive than the Sun. Let's see if we can find this on bite size. So let's go to science here, and then physics, and then space, stars and galaxies. I think we might need to scroll through some of these quite nice pictures. You can look at them obviously in your own time if you want to. Yep, here we are. So we've got the life cycle diagram of a star. So the questions told us they know stars form in a nebula when clouds and dust and gas are pulled together. Describe how this process continues for stars much more massive than the Sun. So I've gone for, in my answer, main sequence star. They've called it a massive main sequence star, but you don't need to make that definition, that difference. If it is a star much bigger than the Sun, which is along here, star the same size as our Sun is along this side, it becomes a red supergiant. It then explodes into something called a supernova, and then there's two final options. It'll either become a black hole or a neutron star. Now to get, what have I done there? That's better. To get the marks here, all I need to do is to have, because it's 4 marks, is to have 3 stages in the right order. So that's a stage in the right order, that's a stage in the right order, these 2 here are stages in the right order, so that's 3. It's in the right order, I get the 4th mark. So there's a lot of space there, but you actually don't need to do much at all. The command word here is describe. I obviously forgot to highlight that one. It's a bit of a red herring really, because all you needed to do was to list those stages in the right order. Okay, let's get this window big again. There we go. Okay, skin cancer can be caused by radiation from the Sun. The radiation that causes skin cancer is, well, again, it's one of these that you just need to know, and it's ultraviolet. It's ultraviolet radiation you are filtering out when you put sun cream on your body. We've now got one of these things. Hopefully you've seen these in school. You know, it's a Venn diagram, and the way it works is, if it applies to only the left category, which in this case is ionizing radiation, you write it here. If it applies to only the right-hand category, you write it here. If it applies to both, you write it where the circles cross over. And we've got 3 things to put in there: gamma rays, infrared radiation, and alpha particles. So the ionizing radiations are alpha particles and gamma rays. Hopefully you should know those from your physics lessons. But gamma is the only one that's in the electromagnetic spectrum. So gamma goes in the middle, because it's in both. Alpha particles not in the electromagnetic spectrum, but most definitely ionizing, so they go on the left, which leaves infrared, not ionizing, but it is in electromagnetic radiation, so it goes on the right. 2 marks for that one. I think it was 1 mark for having any one correct, 2 marks if you've got all 3. Okay, so another multiple choice one here. Which of these is correct for all electromagnetic waves in a vacuum? Well, their frequency can change from almost anything to anything else. Ask on their wavelength. They're definitely not longitudinal waves. That's things like sound mostly. So the only option left is their transverse, and that means if the wave is going, let's say, from left to right, then the wave oscillates up and down. Let's see if you can find a transverse wave very quickly. That'll do. Pretty small, but I think you get the idea there, that the transverse wave, if it's moving across here, it's going up and down, rather than the other sort of wave, which oscillate in the same direction as a vibration, in the same direction as the direction of travel. Okay, back to the paper then, because we're nearly done. Oh, there we go. Okay, so we're now asked to describe a use of gamma radiation. So for this one, it's 2 marks. The marks are for stating a use and describing what it's for. So all we need to say here is, can be used to sterilize surgical equipment. Perhaps I've been a bit short with my answer there. Perhaps I want to say as well that by sterilizing surgical equipment, it kills bacteria on the surgical instruments. But it's one of those questions where you don't need a huge amount of detail to get the 2 marks. Okay, carry on then. We really are nearly done. So ultrasound has many applications. Ultrasound is used for, well, it's not used for cooking. It's not used for communication with satellites because it's sound. It can't get through the vacuum of space. I'm not sure how it could be used to detect forged banknotes, so it certainly doesn't do that one. So the only option is for communication between animals. And animals that have high-pitched or can make high-pitched noises, the chances are they'll be communicating with ultrasound that you can't hear as well. It then asks us to explain why ultrasound rather than X-rays are used for fetal scanning. Hopefully you know that fetus means unborn baby. And the reason is pretty simple. X-rays are ionizing and so can harm the unborn baby. Ultrasound is not ionizing and therefore is safe to use. 2 marks. Okay, we've now got another question with a graph. Sorry, again, the quality is not great. We've got a filament lamp and we've got an energy-saving bulb. It says they both produce the same amount of light energy in the same time. The surface of the temperatures of the lamps change in the first few seconds after they've been switched on. The graph shows this information for both lamps. It says here, and I'm going to make a bit of a point of this one, use the graph to state one advantage and one disadvantage of using an energy-saving lamp. So we've only got to state them, we haven't got to explain them, and we have to use the graph. So anybody that answered this and they use some of the background knowledge they got about energy saving and non-energy saving lamps, you don't get the marks because you weren't using the graph. So I've done it in order. The advantage first. The advantage of using an energy saving lamp using only the information from the graph is that it has a lower surface temperature. Now that means that less energy is wasted, but we don't need to do that, we only have to state. The disadvantage is it takes longer to reach maximum temperature. So they're at maximum brightness here where the line is horizontal, and you can see the filament lamp, it did it in, I don't know, about 20th of a second or something like that. The energy saving lamp took nearly 2 seconds to reach maximum brightness. But again, we don't need to explain, we just need to state, and that's what we've done here for 2 marks. Another efficiency question, you can see the efficiency equation is here. The efficiency of the energy saving lamp is 40. The energy saving lamp is supplied with 15 joules of energy. Calculate the amount of energy transferred to light energy. So light energy is obviously the useful one. But for this one I've got to do some rearrangement. So this is how I've laid it out. I know that 40 is my efficiency. The useful out is what I don't know. But I know the total in is 15. And obviously multiply by 100 to get it as a percentage. So what I need to do is I need to rearrange the equation to make useful out the subject. So the way I've done that, and again this depends on your math skills really and how much math you've picked up so far from your math lessons, I'm going to divide by 100, divide both sides by 100, which gives me 40 divided by 100. Then I'm going to multiply by the total in 15. So it becomes 40 divided by 100 multiplied by 15. And when you evaluate that on a calculator, you get an answer of 6. Okay. Moving on then, why do the lamps reach a constant temperature even though energy is still being supplied? Again, this is a question that not many people got right. It's only 1 mark though. And it's simply because when they reach a constant temperature, they're giving out as much heat energy each second as they receive. So it's like a constant flow in, flow out situation. They get the same amount in as they give out each second, and as a result, everything stays steady. 15. So we've been asked here to put some objects in the universe into smallest to biggest. The 3 objects are the Milky Way, the solar system, and the universe. Hopefully you know the solar system is the smallest. The Milky Way, the galaxy that our solar system is in, is the medium one. And as the universe is everything, the universe by definition has to be the biggest. And if you knew that, if you knew the universe was biggest but you didn't know the others, you could take a guess from A or D because they're the only 2 where the universe is shown as the biggest. Maybe that helps, maybe that doesn't. Okay, part B then, some visible light telescopes, and visible light means using the light that you can see, an optical telescope. Other visible light telescopes are located on the Earth's surface, so some in space, some on the Earth. Explain why the images produced by telescopes on Earth are less clear than the images produced by telescopes in space. So we need to state a reason and then expand a little bit on it. So images from Earth are less clear because they are distorted by the atmosphere. And the 2 marks are for saying the atmosphere, so the telescope has to see through the atmosphere is what I'm implying here, and the atmosphere distorts the image, and that gets me 2 marks. Okay, cracking on then. We've now got a diagram about redshift. Again, it's a bit blurred, but you can see these lines here. You can see they match up, but they're shifted further to the red end as we go from the Sun to Galaxy 1 to Galaxy 2. It says, explain what these redshifts predict about the position and movement of the 2 galaxies. So position and movement. So I've said, for 3 marks, redshift happens when the objects move away from the observer. As a result, both galaxies are moving away. But as one shows a greater redshift, it must be moving faster. So I've explained the movement part. If one is moving faster, then by definition, it will already be further away from the observer than the other one. And that's where I've explained the position. So I've said what redshift is, I've explained how the redshift affects the movement and position based on the two different redshifts of galaxy 1 and 2. Okay, so we now want a question about sonar. The boat sonar sends out pulses of ultrasound, they reflect from the seabed, the boat detects the reflections, and the graph shows what's going on. So the pulse was sent out at 0.1 seconds, and the pulse was received with a lower intensity a little bit later, or lower signal strength on this graph. How long did it take the pulse to travel to the seabed and then back? So 0.1 seconds to about 0.38 seconds, which means 0.28 seconds in total, 0.38 minus 0.1. It then says the speed of ultrasound in water is 1500 meters per second. Calculate the depth of the sea floor under the boat. So if this isn't obvious, what's happening is the sound wave is going straight from the bottom of the boat, straight down to the seabed, bouncing off and coming back to the boat. And if you know how fast the sound goes, and you can time how long it takes to get there and back, you can use the speed, distance, time equation to work out how deep it is. So I'm going to plug the numbers into the equation. The distance, what we need, is the speed, 1500, multiplied by the time, 0.28. But it's not quite that simple. If you did that and then pressed equals and wrote the answer there, you get 2 marks out of 3. The third mark, you need to realise that if you want the depth, but you've recorded how long it takes the sound wave to go from the boat to the seabed and back to the boat, you've actually timed how long it takes for twice the depth, the there and back distance. So I need to divide my answer by 2. And that's the third mark, and that means the answer is 210. Last bit of the paper, you'll be glad to know. We've got an athlete doing the high jump. Which forms of energy does the athlete have at the top of his jump? Well, the athlete at the top of his jump will be moving across by a small amount because he's got to clear the bar. You can't see it in the picture, but you must have seen this on TV or something like that. There's a bar across here that he's leaping over, and if he was stationary, he wouldn't be able to move across the bar. So he must have some kinetic energy, but also he's jumped from the ground level up here, so he's gained gravitational potential energy. So the correct answer is B. Finally, the athlete gets the energy he needs for his jump from his food. Complete the sentence. The form of energy stored in his food is chemical. Some people have said glucose for that answer, and it's fair enough. The energy is stored in glucose, but glucose isn't a form of energy. Glucose is a chemical, and it contains chemical energy. So that is the correct answer. Okay, that's the end of the paper. I hope this screen record video has helped you fill in the blanks for the mistakes that you made.